Hello, everyone. So today in 6.6, we are going to do systems of linear equations. This time we're going to do it determinants, okay? In this section, we assign to each square matrix A real number called the determinant of A, which will lead to another technique for solving systems of linear equations. Two commonly used notations for the determinant of matrix A are the DETA, or it looks like absolute value, but it really means determinant, okay? So be careful with that. Now, yes, this is giving us another option to solve systems. So if you get a question that says solve the system, you can pick whatever way you want. But if you have a question that says solve the system using determinant, or later you'll find in this lesson, solve the system through Cramers Rule, you do have to follow what procedure it's asking for, okay? So let's go from here and look at determinants. Finding the determinant of a 2x2 matrix. So the idea is we have a matrix of A, B, C, D. The determinant, so DET of A, is A times D minus B times D minus B times C, which is that crisscross, okay? So again, it can be denoted this way instead. Hopefully, this part right here looks a little familiar from what we were doing in our inverses last class. So what we're going to do right now is compute the determinant of the matrix A. Now, you do need to denote that you're going to do the determinant. So I'm going to say determinant of A equals, and remember it is A times D minus B times C. And when I do that out, let's say get 4 plus 6, which is 10. So the determinant of this matrix A is 10. So as you can see, this little stuff down here tells you we've seen the determinant before. We used it when we solved for inverses, okay? So of course we have that little trick when we are doing a 2x2, but what happens when we have a larger scale? So think of an n by n matrix, okay? So one method of finding a determinant is called expansion by minors or expansion by cofactors. In this method, we rely on our knowledge of how to find the determinant of a 2x2 to help us, okay? So I want you to see the pattern here, and you'll find this will make sense when I start to go over some other things that might be involved here, okay? So it depends on the row we have, okay? Now, what was it? Here we go. So as you can see, I always start with the positive or addition in the front, okay? The subtraction, and then it goes vice versa either way. It also goes that way vertically, okay? So always start with your addition, your positive in the corner, and that way you can figure out, hey, am I adding or am I subtracting? That will make sense in a minute, okay? All right, so here's our theorem here. Given an n by n matrix A, where n is greater than 1, the determinant of A is the sum, and there's my highlighter, the sum of the entries in any row or column multiplied by each entry representative cofactors, okay? Now, what does that mean? Okay, we have our 3 by 3, right? The idea is this. Remember that when we were talking on the other page about this being positive, meaning plus, minus, plus, minus, plus, minus, plus, minus, plus. Now remember, that's not about positive, negative, even though we kind of go back and forth with it. It's actually our adding, subtracting. Now, The sum of the entries in any row or column multiplied by the entries represent respective cofactors. Okay, so what does that mean? Well, here's a great way to do this. Pick one row or column. I would suggest, I would suggest always sticking with the same thing so that way you don't get confused. Now, if I pick row 1, right, I'm going to start with my 3. So I'm going to denote this a different way. I'm going to do determinant of A equals. Now I'm going to start with 3. Okay. And when I look at 3, I'm going to kind of ignore the column of 3. And I'm left with like this new 2 by 2, right? So it's almost as if I have this -1, 5, 1, and 4. Now, what I'm going to do is I'm going to continue with these numbers across the row and add them all up. But again, adding, subtracting, this one right here, it is in the subtraction spot. So I'm going to subtract 1. Now, when I think of the new 2 by 2 here, I have to ignore the column of 1. And as you can see, if I ignore the column 1, I'm left with 0, 5, 2, and 4. Now I'm going to add, I'm going to look at the 2. Now if I ignore the column of 2, I'm left with this 0, -1, 2, and 1. Now this looks like what we were doing before with the A times D minus B times C, and that's what we're going to do with it. So right now I have 3 times -1 times 4 minus B times C. Okay, so that's my whole 3 one. I have this -1. I'm going to multiply the 0 times 4 minus 5 times 2. Okay, that whole thing is multiplied by the -1. Then I have this plus 2. I have 0 times 1 minus -1 times 2. Now be careful on your arithmetic here, because either you can put this on your calculator at once, but be careful on those parentheses, or do little by little. I tend to do little by little just so I know I'm not forgetting anything. So I might, my calculator, just do this inner spot here. So I have 3 times, and that's -4, minus 5, which is -9. I have this -1 times, well, that's 0, and that's -10 plus 2, and that's minus a -2, so that is going to be +2. And now I can even break that up more, and I can calculate this on my calculator. I feel fine with that, and I get the value of -13. Okay, now I'm actually going to do this really quickly just to show you that I could pick any column or any row for it to work, but you need to do it based on the cofactor, okay? So if I try, let's see if we come up with the same thing. Let's try that middle row. I know that middle row is going to be a little bit weird to see right now. Okay. So really, this would be -0. But of course, when I do anything with that, do I even have to fill it out, guys? Because when I multiply by 0, I get 0. So I'm not going to have to worry about that. Now I'm going to add this -1 times. Now, if I had crossed out this row and I crossed out the column of -1, I am left with 3, 2, 2, 4. And my last one right here, which would be -5. If I'm done with this row, done with this column, I'm left with 3, 1, 2, 1. Now again, the only reason why I didn't fill this out, guys, is because anything times 0 is 0. Now, so I'm going to ignore that right now. I have this -1 times A times D minus B times C. Sorry, my 2 looked weird there. Minus 5 times 3 times 1 minus 1 times 2. And this time I'm going to do it all in my calculator, and even you can try it out to see that you come out with -13. 3 times 4 minus 5 times 3 minus 2. And what do you know? When you do this out, guys, you get, and you can see I got it on my calculator, -13. Okay, so that was me just proving to you that you could use any row or column you want as long as you're doing the correct adding or subtracting there. But I would stick with the same thing always, so you're always in the same habit. Okay, so that is one way that we can find the determinant. The other thing that we can do is we can use the diagonals. So here's what we're going to do. When we rewrite the first 2 columns, rewrite the first 2, I'm pretty sure that's supposed to be a TOW. Rewrite the first 2 columns to the right of the determinant. Draw diagonals from each element from the top row downward to the right. Find the product of entries in each. Okay. Then draw diagonals from each of the bottom row upward. Again, I'm going to show you how to do this in a minute. Add the products of the first and subtract the products of the second. Okay, so what I'm going to do right now is first I'm going to do step 1, which is rewriting this matrix and putting the first 2 rows also next to it. So watch what I do. So I have this, the original, right, which is 3, 1, 2, 0, -1, 5, 2, 1, 4. What I'm going to do is separate, just so I remember, like this is where my matrix was. And I'm going to add those 2 rows. So 3, 1, 0, -1, 2, 1. Okay. Now, what I'm going to do for you is kind of use colors so that way you can see where I'm getting the numbers. This is a 3 by 3. So when we talk about the product, how it said the product of the diagonal, you want that many numbers. So I'm not going to start with 2, and I'm not going to start with 0, 1. I'm going to start with 3, -1, and 4. So the first thing I do is I have 3 times -1 times 4. Now, all the ones that I'm starting at the top and going down, I'm going to add them. So my next one here, 1, 5, and 2, I'm going to add 1, 5, and 2. Again, this is a 3 by 3, so I should have 3 numbers and 3 diagonals. Next, one more diagonal, right? I have a 2, 0, and 1. So again, I started at the top, so plus 2, 0, and 1. All right, so here's the tricky part, and I might not use another color this way, or I'll use a darker one since you guys can see what I'm doing already. I'm gonna stop saying So if you go from bottom to top, I would start, I guess either way, I can start here, bottom to top. Now, when I start bottom to top here, and I'm going to the right, going up, I'm going to subtract it. So 2, -1, 2. Now I'm going to keep using green just so I don't offset colors. Okay, my next one, again, I went bottom to top, so I'm going to subtract 1, 5, 3, and then here one more, subtract 4, 0, 1. Perfect. Okay, and now I'll do my math, right? So here, the first one, when I multiply those out, I get -12 plus 10 plus 0. Okay, be careful. This is a minus, but it's going to be negative. So I'm going to go plus 4 minus, well, that's 15 minus 0. And when I do all that out, what do you know? I get the same thing. I get -13. Remember, this was the matrix that we just did above. So we already knew the determinant was going to be -13. So we're able to do our diagonals. Now, just to be if you're a little bit confused about what I did here compared to here, is look, there's an extra set of parentheses here, right? So I would distribute that out. So if you want to remember it, that you are going your diagonals this way minus your diagonals this way, go for it. But don't forget that negative is distributed all the way. That's why for me, so I didn't have that extra set of parentheses, I just decided to subtract all of them that went this way. Okay. All right, so those are some ways of how to find determinants. So what are we going to do with it? Well, we're going to use the determinants to solve for linear equations, just like we've been doing, but in a different way. When we use determinants to solve for linear equations, it's what we call Cramers Rule. Okay, so this is a lot of stuff on this page. So I'm going to try to summarize it up. Suppose matrix A times your variable matrix equals a constant matrix. So for n linear equations, n unknowns, where A is the coefficient, I already said that. If the determinant does not equal 0, then the corresponding system is consistent and independent, and the solutions are known as your x1, x2, x3, or xyz, things like that, okay? So what I want you to notice down below is how we would solve this system, okay? So first of all, if you look at the denominators below, this is a 2 by 2, right? Well, not 2 by 2, but it's an xy equals xy equals. So we are able to solve for the x value and the y value. Okay? What we do is we have your matrix determinant in the denominator. You guys see that? But what do you notice about the numerator? If you notice this, the constants are replaced where that variable would have been. So as you see, these values would have been our x values, but since we're finding x, we put the constants there and then take the derivative. For our y's, these would have been the y values, but we put our constants in that place, and then we find the determinant. Same thing down here. And of course, this gets a little bit longer, right? Because you have your original determinant of the matrix. Okay? That's always a must, because where does that go? That goes in the denominator for each of those variables we're solving for. Then to find the x, we need that determinant of the x. So what we do is we replace the numbers for x with the constants. For y, we replace the y's with the constants. We replace the z's with the constants. Okay, that's the idea of it. So let's practice. Okay. All right, so here we go. First of all, we're going to want our determinant of our matrix. So the determinant of our matrix equals 2, -3, 5, and 1. Okay, so when we do that, remember that's 2 times 1 minus -3 times 5, which gives us 17. Okay, we're going to need that for both. Then we need the determinant if we are solving for x variables. Okay, so instead of 2 and 5, I'm going to put our constants, which are 4 and -2. The y's stay there. All right, so 4 times 1 minus -3 times -2. What does that give us? That's 6. That's 4. 4 minus 6 is -2. Then we have our y, so determinant for our y. That means we keep our x's, which are 2 and 5, but instead of our y's, we're going to put our constants of 4 and -2. Okay, so 2 times -2 minus 4 times 5. So what is that? -24. All right, so we got each of our pieces. I would say do each of your pieces first, because the x value, okay, will always be your determinant of your x over your original determinant. So for us, our x value is going to be -2 over 17. And for our y, well, that's the determinant for our y's all over the determinant of the original matrix. So that gives us -24 over 17. Can you check your answers? Yeah, you can. You can plug in to make sure it's true for both statements, and you are all set. All right, so having this like 2 by 2 solving for the determinant is a little bit easier, right? But when it comes to a 3 by 3, it's a little bit different. Okay, now I want you to pay close attention here, because in example 6, we actually go through a whole bunch of stuff, but here it only says solve for z. So we don't have to solve for y. We don't have to solve for y. We solve for z. Okay, so let's do our original. Now with this, you have to choose. Are you going to do it where you pick a row and then you summarize all the cofactors and things like that? Or are you going to do the diagonal? That's going to be up to you. Okay, so let me write this down. 2, -3, 1, 1, -1, 1. Be careful here. 3, 0, -4. Okay, so I could do it where I'm crossing out and multiplying by that 2 by 2 stuff, like we did at the beginning, or I can do the diagonal. I'm going to do the diagonal. I like them better. So I'm going to write the first two columns again. All right, so I'm going to try to do it this time without actually drawing the diagonals, but I recommend keeping in mind the diagonals so you don't mess up. So I go 2, -1, -4. I'm still adding because I'm starting at the top. So add the -3, 1, 3. Add still again. 1, 1, 0. Okay. Hopefully you don't run out of room. All right, so I'm going to subtract. I'm going to start down below here. So 3, -1, 1. Subtract again and get 0, 1, and 2. Subtract one more. -4, 1, -3. All right, let's put all of this together and see what happens here. Let me get my calculator. So this would be, you know what? Here's another great thing. If you use different colors or you space them out normally, I can write it on top. So this is 4. 4 times 2 is 8. Then I have -3 and 3 is -9. 0. Okay, so this though, I might include the negative, so that way I'm just adding straight across. So this would be a +3. This would be a 0. And this would be a, let's see, that's +12, but we're subtracting it, so a -12. Now let me get my calculator, see what happens. Did I just have a twang with my voice, guys? -9 +3 -12. I get -10. Did you guys get -10? Okay, so remember, that's just the determinant of the regular matrix that I put in the denominator. And I'm only solving for z. So the good thing is I just replace the z's with our constants. Okay, so I'm going to keep this 2, -3, 1, -1, 3, and 0. Now for these z's, instead of writing the z's, I'm going to put the -1, 1, and 0. I'm going to do the diagonal again. Now it's these first two columns. So 2, -3, 1, -1, 3, and 0. All right, let's do my diagonals. So let's see if I can go a little faster this time. 2 times -1 times 0 is 0. And I'm going to add, sorry guys, you can't see that. There we go. -3 times 1 times 3 is -9. Plus -1 times 1 times 0 is 0. Now I'm going to go down here because I'm going to go up. So I'm going to subtract. 3 times -1 times -1 is 3. Oh, there's your bell. 0 times 1 times 2 is 0. 0 times 1 times -3 is 0. And what do we get here then? We get -12. So the z value is the dz, which is -12, all over the determinant of the matrix, which is -10. And of course, if we simplify this, we get 6/5. All right, I think you got it. Let's see what the next one brings us, because this one hopefully shows us maybe either how long this could get or maybe a no solution, okay? All right, let's find our normal matrix determinant. So I'm going to put D here. I get 1, -1, 1, 2, -3, 4, 5, 1, -2. Okay, I'm going to do my first two columns. I get 1, -1, 2, -3, 5, and 1. Let's do my diagonals, right? See if I can do this math quicker. So 1, -3, and -2 is a +6 plus 5 times 4 times -1 is -20 plus our last one, which is 1, 2, and 1, which is 2. Now I'm going to subtract. I'm going to go down and up. 5 times -3 is -15 times 1. Minus 1 times 4 times 1 is 4. Minus -2 times 2 times -1 is a +4. Okay, let's see what happens, guys. Get a calculator out. I don't know why, but you know. Oops. You get -5. Did you guys get -5? Kind of didn't do this one ahead of time, so let's go with the flow. 6. Okay, I'm going with it, guys. All right, that's probably why they give us a whole page to do. So now let me do my dx. Remember, I'm replacing all my x values with the constant. So the constant is -4, -15, and 12. And I'm going to fill in my y's of -1, -3, 1. Plug in my z's, which are 1, 4, and -2. All right, let's do the first two columns there. So because we're solving for all of the variables in this case, it's a little bit longer. The good thing is, because we have all variables, we're going to be able to check our work in the very end, okay? So let's do that diagonal. That's a +12, -24 there, plus -4, so -48. And then plus a -15. Now subtract 12, -3, 1 is a -36 minus, that would be a -16 minus, this is going to be negative, so 30. -30. All right, let's do that in there. 24. Too many plus signs, guys. Okay, I got 43. That looks terrible, but we'll see what happens. Let's check that. All right, we'll stick with it and see what happens, okay? Because this means that x equals 43 over -5. That looks like a terrible fraction. With my luck, I'll probably mess up in the first determinant. So let's do dy. Remember, I'm keeping my x's. So what were my x's again? It was 1, 2, and 5. But instead of my y's, I'm putting in the constants -4, -15, and 12. There are my z's, 1, 4, -2. Okay. Columns, 1, -4, 2, -15, 5, and 12. All right, let's see how this goes. That's positive 30 plus negative, so that's 20, negative 80, wow, that's big. Plus that third column there, or third diagonal would be 24. Minus, let's go this way, 45, negative 45. Minus, that would be 48. Minus, let's see, 2 times 2 is 4. 4 times 4 is 16. That's positive 16. All right, let's see how that goes. 30 minus 80 plus 24 plus 45 minus 48 minus 60 equals a negative 45. That's a little bit better because at least we know that y then equals negative 45 over negative 5, which is a positive 9. So let's try our last one. Hopefully we can check our answer and get this right. All right, we keep our x's the same, 1, 2, and 5. Keep our y's the same, which is negative 1, negative 3, 1. But our z's now are negative 4, negative 15, negative 12. Okay, first two columns, 1, negative 1, 2, negative 3, 5, and 1. Whew. Sorry, guys. There we go. Equals. So right here, 1 times negative 3 times negative 12 is a positive 36 plus, right? Still going that way. Negative 1, negative 15 is 15. 15 and 5 is 45 plus negative 4 and 2 is negative 8 times 1, so negative 8. Now we're doing our subtraction. 5, let's see, let's do it this way. This would be negative 20. That would be positive 60. Okay, next one, minus a negative 15. Minus, let's do a positive 24. 36 plus 45 minus 8 minus 60 plus 15 plus 4. All right, let's see what happens here, because this dz, or not dz, because that's determinant, z equals 4 over negative 5. I'm a little worried for the fact that, see what happens here, guys. Okay, so in our first, I'm going to plug into the first one to see if that works. So when I do that, I would get 43 divided by negative 5 minus y, which is 9, plus 4 divided by negative 5. Drum roll, please. Nope, we did something wrong. So what I'm going to do, guys, right now is that I'm going to pause this video so I can look at my work, and then you'll see right away that I'll be like, this was my mistake. Here's what happened. Okay? Hopefully you found it before I did. So it would have been great if you guys had found my mistakes as you were going. But the good thing is, knowing we did a full prom out, we could figure out our mistakes, and I was able to go back and check them. And I made a lot of little mistakes, and this is probably why I won't redo this lesson, for the fact that these little mistakes are little mistakes that you are going to make all the time. So the first thing I did was I checked my determinant of my matrix, okay? So when I did that, perfect. Okay, it was great. Now, when I went to my x's, what I realized here, guys, is that I did negative 4 times negative 3 times negative 2. And I said it was a positive 24, but it was a negative 24. Knowing that, that would give me a negative 5. So my x value was actually negative 5 over negative 5, which is 1. My y value, let's see, where did I make my mistake? Oh, I made my mistake on 5 times 15. 5 times 15 is 75, not 45. I don't know what I was thinking. This is what happens when you do a lot of math in your head and you go quickly. So use the calculators when you can. What that ended up giving me was negative 15 down here. So y is negative 15 over negative 5. So our y value is 3. On DZ, I actually made 2 mistakes. I made the mistake of writing negative 12 here. It was supposed to be positive 12, which actually messed up these 2 figures right here, these 2 numbers, because one became negative and one was negative over here, which would make that positive, right? But the other thing I did, but yet with that 15 and that 5 again, I don't know what I was thinking, 75. That's why that. When I do all that out, it becomes 10. So z is 10 over negative 5, which is negative 2. Now you can see if you plug in to the very top, I would get 1 minus our y value, which is 3, plus our z value, which is negative 2, and I get negative 4. I can double check that again. I can do that with the second row and say, okay, 2 times 1 minus 3 times 3 plus 4 times negative 2. Hopefully that gives me negative 15, and it does. So checking your work helps you go back to know if you made a mistake or not. Okay, guys? And if your question says use Cramers rule, you're going to have to use your determinants to be able to do that. Sorry for the mistakes, guys.